Example 1, solve the square root of x minus 2 plus 3 equals 0. So what we want to do to solve a radical equation has a square root in it. The first thing you want to do is get the square root all by itself. So anything that isn't the square root moves to the other side. So the square root expression stays right where it's at, x minus 2 inside the radical equals. I'm going to move the 3 to the other side. I'm going to change its sign. Once I've done that, get the radical isolated, my next task is to make the radical disappear, and we do that by squaring both sides. When you square both sides, both the sign and the number are being squared when you do this. So when I square the square root of x minus 2, I'm just going to get x minus 2. So a square root and a square are inverse operations of one another. That's how you get the square root to go away. Over on the other side, negative 3 squared means negative 3 times negative 3, which is 2 negatives make a positive. 3 times 3 is 9. And once you get the square root out of the problem, your final step is to solve for x. This says x minus 2 equals 9. If I move the 2 over here, it becomes positive 2, so we get x is equal to 11. What that represents is the only number in the world that could possibly be the right answer to this problem, but it's not necessarily the right answer. So what I'm going to do is I'm going to circle this. And then I need to verify that it actually works. So to do this, I'm going to go back to my original problem, and I'm going to replace x with 11 and stick it in the problem and try and see if it works. So the problem states the square root of x minus 2 plus 3 is supposed to equal 0, right? Instead of x, though, I'm going to put 11 because that's what x equals. If the correct answer is 11, this will be a true statement. If it's a true statement, we're done. If it's a false statement, we have to throw out the answer. So, if I work out inside the square root, 11 minus 2 is 9. The square root of 9 is positive 3. And 3 plus 3 is 6. So, and it's positive 3 because the square root symbol is already there, so it's the positive square root of 11 minus 2. The positive square root of 9, so positive 3 is what we get out of that. 6 equals 0 is a false statement. False statement simply means the answer we got, which is correctly done over here, doesn't actually exist, so the empty set's the correct answer to this problem. There's no correct answer to that problem. It's impossible.